Sure. Well, I was just going to say hi, and then maybe you guys can both officially introduce yourselves. But yeah, is Christian, are you up front there somewhere?
Hello.
Wave. Oh, there you are. Awesome. Well, thanks for organizing this, and hello, Badgers. Excited to chat with you guys. And yeah, I'm Pete. I've been helping to build the company Flux from the hiring side of things, and also running our internship programs for summers and even for like spring and fall semesters. So always excited to get to know anyone that might be interested in those kind of things. And we did finally post our hardware engineering internship for this summer, as well as a marketing internship. So yeah, excited to chat with anyone afterwards about that. Or share my email. I'm sure Christian can do that. But
Yep,
yeah,
absolutely.
Jenner, you want to say what's up?
Sure. My name is Jenner. I just recently started as a software engineer, and I'm focusing on the simulation and user code runtime aspects right now. So yeah, I'm excited to hopefully get some feedback from you guys around where we should take things next.
Yep, and I'm Kerry. I am an electrical engineer. I have been working with Flux for 8-9 months, some long amount of time. I have been in electronics for 10 years. I was an iPhone hardware engineer, actually alongside Jenner. I worked on iPhones from 2013 to 2018. And then I made some intelligence equipment for special operations groups. So kind of saw both sides of the electronics industry there. Lots of different types of gadgets when you cover that range of space. But I really love talking to college students because I feel like there's not much of a bridge between college and like career space. And this is something that I really missed when I was in college, was someone to help kind of tell me what's going on in industry, like what is it like. And I feel like the formula programs are a huge improvement to that, because these are really these are really serious engineering projects that you guys are doing. And so anyway, that's sort of the long-winded version of me saying I'm excited to talk to you about some of this stuff. Any questions before we get started? I know there was some interest in doing some amplifier stuff. So I'll tune my demo towards that, unless there's any other requests. Cool. Let's get to it. Let me just show Flux real quick. Okay, so this is Flux. If at any point you have questions while I'm talking, just shout out, interrupt me.
Yeah, and I'll bring the microphone around too if you have a question. So like raise your hand or whatever, and I'll run over and make that happen.
Sounds great. We're getting some cardio today too. So yeah, so this is Flux. I'm just going to give you a quick tour. I have actually used Flux professionally a little bit, and one of the things that I think is really relevant in Flux to your guys' use case is that you want to be able to build equipment really quickly. And if you go in and build stuff from the ground up, it takes a really long time if you have to build all of your components and sort of go through this whole process. So I think there was some interest in like instrumentation amplifiers and strain gauge type stuff. So we're gonna look a little bit into that space. Two quick things I want to start off by showing you is Flux is very community driven, and so there are tons of parts and boards that already exist in Flux, and those are public, and you can use any public project as a jumping off point for the work that you're doing. One of the things that I like to do when I have an idea is I just look through this featured projects page, and I see, like, I don't want to start from scratch. It takes a lot of effort to do that. Not that that's a horrible thing, but we want to move quickly, and we want to be able to build and test our projects faster. And so we start from a jumping off point instead of from scratch. So we have a bunch of templates in this space. There are also full projects that you can start from, but say you wanted to go and build like a instrumentation amplifier for your strain gauge front end, if you wanted to measure the small signals coming from a strain gauge, you could maybe start by prototyping that on an Arduino shield. And that removes a lot of the cost and complexity of building your own microprocessor board, as cool as it is to do that. And it helps you focus on the system that you really care about. And so this is what's known as a template. This project includes all of the complexity that's needed in order to create a shield, and you don't have to like go and measure out the position of all of these holes. It's already done for you. And you can see, excuse me, you can see that the Arduino board is already here, and so you can see how it matches up with that board. So in Flux, something that's a little different from other electrical design software is you can fork other people's projects, very similar to the software space. So what I like to do is go through that featured projects page, find something that's similar to what I want to do, and then fork it. So this is now in my profile, and I have total control over it. We're talking about instrumentation amplifiers and strain gauges, and so let's see if we have any. Yeah, looks like we got a couple here. This is another really cool part about Flux is that you often don't have to make your own parts. I think, I'm not sure how many of you have like used Eagle or a different software in the past where when you have an idea and you want to make a board, you got to go and make all your own parts first. That's such a long process. And I'll be honest with you, like I'm a little bit lazy when that happens. So I don't really want to do that first before making my project. So I love this about Flux. You can just go in and you can look for the parts that already exist, and you can use those. And we can see we actually have quite a lot of instrumentation amplifiers here. I think, would it be helpful if I talk a little bit about, I think you guys are interested in doing strain gauge like analog system. Are people pretty familiar with that, or should I talk a tiny bit about what strain gauges are?
It would be nice to have someone talk about it for sure. A lot of people aren't necessarily aware of the project or strain gauges and how they operate and everything like that.
Cool. Yeah, let's talk about it a little bit. These are what strain gauges are. Strain gauges are really helpful for measuring deflection in mechanical systems. Often you'll use them on aircraft or race cars, or people use them on bridges, for instance, to see if they're going to fail at some point in the near future. Hopefully they don't. I really like them because it's really hard to get a sense of what's going on in a mechanical system in a real sense. You can run as much FEA as you want, but when the car is going around a turn and you're loading up all of the shocks and whatever, you want to know what it's actually seeing in that moment so you can make it lighter and you can make it faster or whatever. So these are really helpful for doing that. Strain gauge is essentially a resistor that's on a film, and it looks a lot like this. When you place that on a mechanical surface, the distance that this element travels is increased or decreased depending on the strain, and so that's how you measure a change in Flux here. So these are really hard to use because you can imagine that the resistance change of bending a little piece of plastic is really small, and so you have to go and measure that. I didn't prep this, so let's hope that Wikipedia has the right things here. Let's see, Wheatstone Bridge. How you measure strain gauges, or how you measure anything that's a really small resistance, is that you use what's known as a Wheatstone bridge. You have 4 different resistors here. 3 of them are matched typically, and 1 is a strain gauge, and that strain gauge is a variable resistor because that changes. When these 3 are matched, you get, or when all 4 of these are matched, you get the same voltage at B and D, and so your VG, I assume this is V gauge, is going to be, the difference between those is going to be 0. And so that would be your no strain position. As soon as there is strain in the system, that strain gauge is going to change resistance. And then the voltage here is going to change. So you'll see a different voltage here than you will see here because this resistor divider is different. That signal is going to be really, really small because say you have like 120 ohm resistors here, this is going to change by like 2 ohms. And so you're looking for a very, very small change. Usually that voltage is on the order of like, I think it's like 10 microvolts, maybe 20 microvolts, maybe even lower than that. I worked on a system at Apple. I don't think I can talk too much about it, but we were measuring in the nanovolt space. And that was a really difficult problem. So this is a cool thing that you guys are working on. So you need some way to amplify these voltages, and so that's where the amplification comes in. Let's see if we can talk real quick about instrumentation. This is now less about Flux and more about electronics, but we'll get there. We'll get there. So you need to amplify that signal, and so you have something. I think it was like B and D before. So you're going to attach those to 2 sides of the instrumentation amplifier. You do some fancy stuff with it, and then you get a usable signal out. You can boost the signal anywhere from like 5 times to like 1,000 times. And so these are really helpful for doing that type of work that you're looking at. Yeah, so that's high level on strain gauges. And so, you know, typically when you build a strain gauge system, you have to have some way to sample these things. You have to have some type of an analog to digital converter. You have to have an amplifier. And so that's what we're looking at here is one version of an instrumentation amplifier. Let's just look in here and see. So this is now a little bit more about Flux. This is the community library that I was talking about before. We have information about all of the parts that exist here. And one of the cool things that I really like is that you just get a datasheet link in place and you don't have to go like open a new tab and hunt for it. So this looks like a pretty cool instrumentation amplifier. So we could probably use that one. And by the way, I'm happy to do a follow-up if you guys start going through this design process and want some tips. I can help you out a little bit on that as well. So you know, let's just do this really quick. We don't have to do anything crazy here. There's an instrumentation amplifier, and that's going to have like a gain. And then an input, and then we have an output over here. I'm just going to do this super rough because you don't have to watch me build an entire circuit. That would be really boring. I really love in Flux that you can just kind of like search for what you want, and if it exists, that's great, and you can just use that. You don't have to, I don't know how many of you design electronics already, but you don't have to go search like DigiKey and go find random parts and then try and manifest those parts. You can just see in your app that you're building this stuff in what exists and what doesn't.
Kerry, can you share the link to the project that you're in? Just throw it in the notes if people want to actually hop into the project.
Yeah, absolutely. So yeah, one of the other features of Flux is that it's live online multiplayer. So I just changed the sharing permission so anyone can come in here. I'm going to do anyone can comment for now, and then when I'm done, we can change it to anyone can edit. And I'll send the link to you all. I'll put it in the vowel notes, the call here, and then you guys can jump in. Anyone can, as many of you as want to jump in can jump in.
The live editing is actually really cool, especially for like a team like us where we can kind of work together and simulate things at the same time and make little changes.
Yeah, and just see what each other's up to as well. I mean, I remember meetings when I was an electronics person on my formula team at RPI. I would get up and give presentations of like the things that I was working on. Why would I need to do that when I can just have everyone in the room in the same document with me? And so we can leave comments for each other. We can be like, hey, why did you pick this OpAmp? See if we can break the record for people in a single document. I think we're at like 30, 40. That's the most I've seen. See if we can get higher than that.
We can grab the mechanical engineers and
Yeah.
Yeah, I saw
Oh,
over
is this?
200 after the competition that we had, checking out some of the winning projects. So
Awesome.
it's crazy.
Yeah, I'm also glad to hear this is mostly electrical engineers because I was afraid that I was boring all of the mechanical engineers.
this is only electrical engineers, to my knowledge.
Awesome. Maybe there's some spies in there. We don't know.
Technically.
Nice. So yeah, this is what's going on. You guys can right click anywhere. You can leave comments. I think you could also even potentially go into this on your phones. I don't know how much that's supported right now, but just do it at your own risk. So we placed a couple components here. I'm going to jump over to the PCB just to show you a little bit about that because I think I've talked enough about schematic. And so now we're over here and we can actually route this board. And we have a resistor here. We have our instrumentation amplifier. I think I actually need to make one more connection, but it actually doesn't matter. All right, so we have two things here. It's going to move our components around. Sweet. Clearly you'd want this to be, oh wow, that's not what I intended to do. Anyway, we'll just leave it where it is. So we want to connect these things up. Tracing is pretty straightforward. You just click on the dots instead of, I think, like other tools, they have you select like the wiring tool and what type of wiring you want to do. It tries to intuit a lot of those things from you. And so we would probably be careful if we were being really serious about this. We would try and protect these signals and make sure that everything is looking very good. Connect here. Clearly, we all know that this isn't a full circuit. We have to actually connect it to something. So let's connect it to A0 so that we can actually sample what's coming in from this strain gauge system. All right.
While you're like connecting
go ahead.
things, do you mind if I ask a few questions about?
Yeah, please do.
Yeah. So one kind of question that I had is, you have like this kind of library of parts that have been made and stuff like that. And sometimes, a lot of times, parts will go out of stock, or you have to use something that has slightly different characteristics. Is there a way to like kind of edit the characteristics of a component to kind of see what would happen? Like, for example, for us, right? Like the reason why I want to ask about the operational amplifiers is we haven't done a lot of sensitive analog circuitry on our cars. It's a lot of like tossing power around. And so it'd be interesting to see like, okay, if we change the slew rate of our amplifier, what kind of effect does it have on our output and stuff like that? Like, is there a way to kind of, I don't know, mess around with some of the parameters of your different amplifiers so that you can like kind of learn about them and then be able to make better design decisions from that? Because I think for us, it's kind of, we want to use this as a way to both validate and as kind of like a learning tool, so people have a place to like try out circuits without needing to necessarily purchase PCBs and put them together, or breadboards and stuff like that.
Yeah, totally. That's a really great question. We have a couple things in that regard. I'll talk about one of them real quick, and then we'll talk a little bit more about the simulation part of Flux, which I think will be really interesting to you. Let's talk quick about like alternate parts and specificity. I think one of the problems that you mentioned is that when you're going to build a board that has a bunch of parts on it, sometimes the vendor will be like, hey, I can't buy those parts anymore because someone in China shut down a factory or COVID or whatever. And so one of the ideas is, why do you even need to specify your parts until the time of manufacture? Like, of course, you want to know the general characteristics of those parts. One of the ways that we've started thinking about that is through the idea of generic components. And so one thing that's bothered me is when I have an idea for a circuit that I want to create, and this instrumentation amplifier is a good example. because this is the gain resistor that we put in a generic value of 500, but I don't know if that's what I want. If I wanted to go and put in this resistor in Eagle, for instance, I would have to go and find a manufacturer part number, make the part, and then put the part in here. But that's so specific, and I don't actually have a specific idea of what I want yet. And so these parts, you can change anything about them. We can say that this is 100 ohms, and of course you can change the value in any other program. But you can also go in and add a manufacturer part number later without having to create a part. And then when we go to PCB, you can go in and you can actually change the package of this part. And so you could say, hey, I started with an 0603 part, but actually what I want is a 1206 because we're going to have a bunch of current through this, for instance. Then you can just go in and change that. And so that's one way to be a little bit more agile in Flux, is not specifying exactly the part that you want until the very end. It's easier to do with passives. It's harder to do with things like instrumentation amplifiers. You sort of design your system around that. I want to talk about one other thing here, and then we'll get into the simulation side of things. So one of the things that I think is really cool is that Flux does a lot of work for you. So I think tons of other tools have copper fills, which is just a flood across the entire PCB of some particular net. In this case, it's ground. What other tools don't do for you is stitching vias, which is how you connect all of your different ground planes together. And so we want to take some of the busy work out of this. And so you don't have to go around and manually like place all of these vias. We create an automatic grid for you, and they're virtual nodes. And so when you move your components around, it'll remove some of those nodes for you. And then you don't have to worry about it, and your grounds are all stitched between the layers. And that's pretty nice. We want to make it possible to do high quality designs by default. And so you don't have to know all of these little tricks in order to have a really high quality board. You can just open a board in Flux and start working on it. And then it should be pretty high quality. So I want to get back to the rest of that question, which was about component types and simulation. I'm just going to do a quick intro to the simulator. Jenner's going to talk a little bit more about that in a minute. This is our simulator, and I can actually send you guys this link as well. And you can check this one out. Put this one in the notes too. All right. This is just a cool simulator example. This is a, I think it's an A-stable multivibrator circuit. Yeah. So you can see a lot of different things are happening in the circuit. We have our battery, and we're specifying a particular voltage. We can see the current that's coming out of that battery. We have two different BJT paths. I mean, this is essentially an amplifier. And then we have an LED here. One of the things that's cool is that this LED, someone in the community made that part, and you all have the power to make parts that are that complicated as well. This LED flashes when there's current going through it, but it doesn't just flash whenever there's any voltage. The creator of this part actually programmed in the threshold voltage, and so this LED is turning on when it actually would in real life.
I think you can actually set that as a property. The forward voltage.
There we go. Yeah, forward voltage you can set here. And so they programmed in a lot of that flexibility. I want to talk about that more in a moment. But yeah, you can tweak a bunch of the settings here. There are parameters here that you can change. So the LED, the threshold voltage is one of those options. I think that these are all generic components as well. Oh, this is an actual part number, but that doesn't totally matter. So you could go in and for instance, if you, this is maybe a contrived example, but if you had a capacitor here, and this is an electrolytic or an aluminum capacitor, and maybe they could only get tantalum or whatever, you could go and change the value and some of the characteristics of this capacitor so that you could see how that affects the simulation. And just to go a little bit more into some of the things that are happening here, I wanted to demo for you an OpAmp amplifier circuit. So we have a waveform generator here. We have an OpAmp. We have some gain resistors, and we have a load resistor. We can go in and open some of the parts here and see what's happening in the code browser. So this is how community members have actually programmed these parts. This is actually a little bit of a Easter egg hunt / homework assignment, in the sense that clearly this OpAmp circuit isn't working. We have a particular gain here and it's not giving us that exact gain. And so a challenge for you guys is to go into this code here, watch some of our videos, and see if you can figure out what's wrong with it and if you can make a better solution. I hear we're offering internship interviews to whoever could do that. So I think, go ahead.
I was going to say, I'm sure someone will try to figure it out.
Let's see. Okay, so now I'm going to hand it off to Jenner a little bit. I'm just going to open up this part here. I think he's going to talk a little bit about the code aspect of this, and then we'll go into the future of simulation.
Absolutely. Thanks, Kerry. So yeah, as Kerry touched on, a lot of the simulation here is powered by what we call our user code runtime, and it has a JavaScript-based API that basically lets you take inputs, which are mainly just the voltages on the terminals, and give outputs of what's supposed to be output from your device that you're simulating, as well as any metrics that you want to expose, which is those colored plots that you see there. So it's pretty extensible. One thing Kerry touched on for the OpAmp is we're using a library called Circuit.js, which is decent for the problems we were originally trying to solve with the simulator, which is more focused on like visualizing changes as you're designing the circuit and stuff. But they're really not suited for like in-depth analysis, especially when you get into more tricky situations. So what we've been working on lately is integrating a library called ngSpice, which is it's like a 30-year-old C library. It's very mature, has tons of different models, and it's kind of the industry standard open source for doing circuit simulation these days. So hoping that will definitely increase this simulation accuracy, give it a little bit better performance, and also has a wider community around it that build custom models for it. And I like the momentum the project still has even decades later. So that's pretty exciting. It'll also give you control over more simulation parameters, such as the temperature that you simulate at, which I think could be pretty useful. So that's coming soon. We're also means we're at a pretty interesting inflection point right now, where once we have this new simulator engine integrated, there's a lot more features we can expose to users for doing in-depth simulation. So one thing we've been imagining a lot is sort of just a virtual oscilloscope interface, where in addition to just like metrics that you expose from your simulation models, you could maybe have some virtual probes that you put in if you want to compare voltages across things, and better support for like plotting over small time intervals when you want to make sure that something's changing the way that you expect it to. So to that end, I was curious if any of you have tried existing simulator solutions, such as like Every Circuit. I think Easy8 has a little bit of functionality for that. If there's any features that you haven't seen in Flux that you would really like, or if there is anything just on your wish list that you wish something could do.
I know a lot of us have used LTSpice, is kind of the one that we've interacted with the most. Unfortunately, we actually don't have a ton of experience with Flux itself. I found that LTSpice is a little bit cumbersome to use, and so when I have like heard about Flux, I kind of wanted to be able to move the team into potentially trying to use that as a better solution, especially since LTSpice doesn't have kind of the great sharing capabilities that it has, which just makes it great for doing a quick circuit by yourself for your homework, but not for when like on the team, we're trying to collaborate and kind of show, you know, each other how everything is working and stuff like that. And also,
Yeah, definitely.
there's like it doesn't have like that community aspect of like there's not a lot of part models actually available, so you can really only get very very rough ideas of like what you're actually going to be doing. And a lot of times if you're using like a MOSFET, like a really simple thing, you still can't even get something that has like even similar parameters to what you're actually going to select. So
Right.
we actually have ran into that problem before where we did use Spice for a simulation earlier this year, and it seemed to pass in the simulation, but because like none of the parameters were as good as we would have liked, it actually ended up having some problems once we actually had the board. So when I heard about Flux and you guys offered to show us, I thought it would be a great opportunity to learn, and we'll be sure to let you know as we dig into it if there's things that we would like to interface with and stuff like that.
Yeah,
That'd be
we
great.
love feedback on all of that stuff, and I think that's one of the big challenges, right? Is when you design a circuit and you simulate it, and your board is just totally different from the simulated condition. Like simulators often don't even have a layout associated with them. I think probably no simulators except for the crazy expensive like $50,000 a seat simulators have that capability. And I remember when I was at Apple, we had like an entire team of people whose job it was to tweak those parameters to be exactly as close to the layout as it could possibly be. And even then, it was pretty hand wavy. One of the dreams here is over time that we can integrate the layout aspect of this as well. And so if you imagine this circuit changing with the actual behavior of the circuit that you have, that you've put onto a circuit board, I think that would be really cool in closing some of that gap. And you know, like Jenner mentioned, including some of the information about temperature into the simulation running, because you want to know that your board is going to work at the end of your endurance run or whatever, instead of like, of course, it's great if it works at the beginning, but you want to make sure that it works over the entire course of the event. I remember at RPI, our car got so hot that I think we never finished endurance in it, and it always shut off on us. So that's probably something that we could have made use of.
Yeah, like I mean, something similar to that actually, that would be really cool to see on our side. Is like we route a ton of signals through these long wires all over our car, so you know, ways to like simulate how like those wire connections affect signal, right? Like, okay, if you have 8 feet of wire at this gauge, what does that do to your signal and stuff like that? And that would actually be very useful to see. Just as like a note.
Yeah, that's definitely something that's in NG Spice's wheelhouse, to do transmission line analysis. So we're excited to get that in. To your point though, yeah, basically every Spice-based simulation system is quite cumbersome in itself. So we're hoping with our integration we can, you know, give you all the power of it without all the awkwardness of trying to get into its world. Yeah, there. I saw this quote from a guy that works on circuit simulation at Cadence. He said something like, even though circuit simulators have been heavily used for over 20 years, getting a simulator to converge and give an accurate answer is still considered an art. It's either based on idiosyncrasies of your particular simulator or tricks that are largely based on luck. So hoping to make it so that you're always lucky when you use Flux.
Yeah, and have some of this, have it handle some of that complexity, and I think you'll notice that we didn't even turn the simulation on; it was in the background, and you can toggle different views of different parts and stuff. Like I think half of the complexity is just getting it started in some capacity, and so you know we try and offload some of that stuff. I think as Jenner mentioned, since we have a somewhat custom simulator backend, I would say double check the results in the short term. I think as soon as we integrate NG Spice, we expect the results to be 100% correct all of the time. You know, just take care when you're using it now. Flux is in beta, and so if you see anything that feels strange, you can hit me up via email or Slack or whatever. We have a great Slack community. Maybe Pete can drop a link to the Slack community in the notes of the call. And my username there is just Kerry. You can message me whenever you want.
Awesome, thank you.
Yeah, for sure. Jenner, was there other stuff you wanted to cover here, or maybe we can just go to general Q&A?
Yeah, that's pretty much it. We touched on some of the new simulations that we want to support. Also be curious to know, like, for any of your classes, besides like the projects you're working on for racing. If there's anything that you felt like you couldn't do with LT-Spice, or was too awkward to be able to be useful to you.
Yeah, I'll open it up to the floor because I'm a mechanical engineering major. So
Spy.
I kind of am a spy, but does anyone have any examples of like LT Spice being cumbersome? Alex says he hates LT Spice.
Thanks, me too.
The one thing I think I find the most annoying about LT Spice is trying to find like components. And sorry, I kind of walked in at the end here, but some of the things are like just adding a simple power source you have to go into a search menu to find, or adding a comparator, or like I like that they have the resistor, and I think like a couple things on the top menu, but like trying to find like just a normal power source I was finding it difficult for me to use. Or like even I think you have to input like some sort of command to get it to perform AC voltage. And I remember when we were learning in class, they like just gave us the command to do it, and I can't do it anymore because I'd have to look up how to run an AC voltage out of the normal DC power source. I don't know. Just
Yeah, I think I did that too. I think I remember you have to go into like 3 different submenus, and then there's like one particular type of like menu that you have to go into, and then it's your different types of power supplies. Then you have to specify all the features of the power supplies in order to just get it to work. And it's like, I just want like 5 volts. Just give me 5 volts out, please. I want to answer that a little bit, which is in the Flux library. There's a components with simulation model filter. And so you can go in and just search through the components that have simulation models. We have quite a few here. There's not a ton of really complex parts. I think OpAmp is probably the most complex one we have, but we have resistors, capacitors, fuses, transformers. Here's your DC supply. No need to specify 800 things in order to get that to work. You just drag it in. Waveform generator, etc. So you can do a lot of those things off the bat. I will caution you that many of these are community generated, and so sometimes they don't work exactly as you expect. When we finish incorporating in GSpice, the models will get much higher quality, and then you can just go download models from the internet, add those as assets to your parts. Then you should be able to do all those things. We're excited because that will really increase our reach from simple components and MOSFETs and BJTs or whatever, to full ICs, power supplies, LDOs, things of that nature. Something that I didn't talk about is related to strain gauges. The power system is really incredibly important, and having a clean power supply. And so that's probably something you'll want to incorporate into your simulation. Is not just the op-amp, but probably the power supply chain that's feeding your strain gauges as well as your amplification circuit.
Yeah, one kind of question on that is, are you able to kind of generate quote unquote signals to input to it, right? Because like with a strain gauge, it's not going to be like a sine wave or a square wave. It's going to be kind of like this random jagged nonsense. And so you kind of want to see how the how your amplifier is going to perform when it's dealing with kind of crazy transients.
Yeah, that's a really great question. That is definitely a much more real world case. I don't know, maybe Jenner can answer this a little bit better than me. I don't know that we have the capability to do that yet. I think that we should have the capability to do that once we improve our simulation backend. But I think what you're talking about is it's like an arbitrary waveform generator or something like that. Is that kind of what you're talking about?
That might be the actual term for it. I'm just thinking of it in
Okay.
like if I were to like put a scope up to it and bang the piece of metal against a table, like what would it look like? And it wouldn't be anything clean. So yeah.
Yeah, that's an awesome question. You should, I think that would be something like a ringing step response, and so I think we should be able to do that in the future with ngSpice. I don't think that we can do that exact thing yet.
Yeah, you may want to take a look. I just shared the link to the waveform generator part, which you should be able to access to see its implementation. Yeah, there's not only a way to do that kind of random signal yet, but I think the primitives are there. Basically, for each step, you would just need to output the voltage that represents what you want. It's probably not the nicest way to do this, but it's theoretically possible.
Yeah, you could also like feed it a like CSV file and have it just do that.
That's exactly what I was thinking. That's CSV file import for waveform. How cool would that be if you had your actual strain system and you banged the pipe against the table, as it were, and then measured the response and then fed that into your simulation? That would be really, really cool.
Yeah, that's kind of what I was thinking.
Yeah, that's a great idea. Awesome. Any other simulation questions or general questions? Electronics, career, life,
Yeah,
etc.
handing you off to Calvin.
Hello. Less of a simulation question, more of a back to the like ECAD side of things. You mentioned that like a lot of the models and components are community based. Is there any sort of like vetting or review system? I know I've used some library loaders in the past that have just given me garbage footprints.
You mean like what is it? Easy? No, it's SnapMeta.
Yeah.
We do some library QA. We go in and we take a look at the components over time and see if they're quality or not. I'm just going to get myself back into a project so I can show you that. And you also have some usage statistics. Like you can see that, for instance, this generic resistor has been used 1.2 million times. So something like that is probably pretty safe. This is a very popular push button, the most popular push button in the whole world, 460,000 uses. So these are sort of like some derived ways that you can go in and infer the quality of these parts. Number of stars. We have an idea where we want to do publish the number of times that a user has made a board with this part and then fabbed a board, or maybe like a review system, so that people could say, hey, this part totally sucks because it didn't work and it broke my board. It would be nice to have that feedback in place. But I guess I'm curious to hear from you guys, like what types of things would you trust? Would reviews be good enough, or is there something else that you would look for as a sign of quality?
Yeah, I think some sort of review system would be huge. I don't know. I am always very anxious about my stuff and almost always double check it against the data sheet anyway. But if something is used a lot and has a decent review, I think that would be a good sign for sure.
Yeah, and then you could say, hey, I checked this part against the data sheet and it's good for me. And then if 5 other people did that as well, you would probably feel pretty confident about using that part. Or even like just upvote, downvote system, maybe downvote to oblivion.
Downvote would be good for sure. Could also even like have community moderators or something that can curate or approve parts.
Yeah, that's a good idea. One of the things we've been struggling with is that there are so many parts that are being made that Flux can't be a central resource to police all of the parts. And so I like this idea of maybe having some community aspect to it. Maybe the community helps police itself, or some people go in and review the parts. Or I think there's a lot of good ideas here.
Cool.
Does anyone else have any other questions they'd like to ask about anything? He's also like a real world electrical engineer, so you guys have questions like that, probably be happy to.
I had a question about the simulation. Is there a way for me to see like how the amplitude of any voltage or current changes with time? Like, is there a way I can like probe like any one point? I know you mentioned like stuff about like a virtual oscilloscope. Like, how would I go about doing that?
So currently the option that you have is kind of the plots that you see here. And so you can see how these are changing over time. Yep. We don't yet have the ability to plot those like on a chart and allow you to inspect those different values. That is part of what we're working on next. And we'd be happy to get any input from you for things that you'd like to see in those types of plots.
Yeah, I think this definitely is a great way to represent just how each of the components are responding to what was happening in the circuit. So
yeah, just like a quick visualization. Probably, I'm sure that we'd all like more input, like if you wanted to see the exact magnitude of different spikes in this waveform, you know, you'd want to get all of those details.
Yep. Thank you.
Yeah, thanks for the question.
Does anyone else have any other questions? You want to ask a question? Absolutely.
Yeah. So I'm actually new to PCB. So when we design the circuit, so how is this just used to help design the circuit instead of like, do you guys also just make the board, or you guys just are software just to help us design the circuit? How does that work?
Yeah, that's a good question. So Flux is somewhat similar to other design softwares. Oh wow, I'm so blurry. Let me fix that. Can't answer questions while blurry. So Flux is similar to other design packages in that you sort of have an idea and you go through the design process in Flux. Your output would be something like this board here. So you do the schematic, you do the layout, you can visualize what the board would look like in Flux. And then you can go and export this board. You would export Gerbers, bill of materials, and pick and place. And then you would go and upload that to another service. I'm just going to show you a little, this is an internal thing, but you can just check out the Gerber preview real quick and make sure that your board will actually match. This is sort of like a manufacturing preview of what you would see when your board came back from manufacturer. So in general, you would go and export those things from Flux, and then you would go to somewhere like JLC PCB.
Hey.
You guys use JLC PCB?
Yeah, it's the cheap option for when you're a nonprofit student organization.
Totally. Yeah, I use it too. I use it to prototype all my boards, and it's huge because I think when I was in college, it was like $2,000 to $5,000 to build and assemble a circuit board, and then now it's like $10, $20, and I would have built so many more boards and definitely had them soldered for me. I remember sitting and like soldering all of them by hand in order to get my boards done. That was a bummer.
Yeah, no, they talked me into doing like the JLC PCB. Like, it's only like $10 extra. They're like, no way, it's only $10 extra. I was like, oh, it's $10 extra. And then the boards came with all the components on it, and I was just like filled with like a warmth joy knowing that like I didn't have to do that anymore. It's fantastic.
It's a long process, right? Like it took me, I don't know, like a day, 2 days, 3 days in order to solder all those components on there. JLC PCB, they're great. So yeah, you just go and upload your Gerber. It's the same as any other software that you guys are using. You just upload your Gerber and then get a quote. I guess I'm not signed in, so I can't show you some of my boards here, but you can just export straight from Flux. And I guess while we're here, maybe someone can ask another question and I'll just upload this Gerber and we can see what it looks like.
Anyone?
How do you guys have like handling design rules and manufacturing capabilities set up with that?
Aha. That's a great question. Let me open like a real project. I have a lot of projects. We'll just start with this one. We have design rule checks. Maybe Jenner, do you want to go in the background and export some Gerbers from one of the boards and just upload it to JLC PCB? I neglected to think of the fact that probably I would need to also answer the question that was asked, so I can't upload it at the same time. So in PCB, we have this panel here. It's called the problems panel. And also you can track all of your comments. We could go in and see. Let's see. I think you guys left me a bunch of comments, so I could go see all of those here. We have a set of DRCs here. We have overlapping wires, missing footprints, invalid layer. This would be like if you tried to put a component that has 4 layers onto a 2-layer board. Component overrides if you change something about the part. And then there's also air wires, like nets that aren't connected yet, and you want to make sure that you connect all of your wires. We have those DRCs so far. We are working on adding others like component spacing, which is a really important DRC check. We also plan to have some more error checks in the schematic side of things. I'm curious if you know of any DRCs or any DRCs that are important to you that we don't have in this list. I would be curious to hear about.
I would say Altium is what we use a lot for our like PCB design, and
Nice.
just kind of their default setup is like I usually have to be doing something pretty specific to deviate from that. So I would say that would be a good place to look for a lot of the setups. And also a big one that they have as well is like manufacturing as like kind of a separate thing. And that way, you know, you can go in and what's it called? Kind of put what the manufacturing specs are for each of your rules. And then something they don't have that would be a cool feature would be if you could kind of save manufacturing specifications. Like, you know, we use like JLC for a lot of our like less tolerance boards, but then we might use advanced circuits or something more precise for like say our inverters or something like that. And it would be cool to be able to just kind of save each manufacturer's specifications as like a file, and then you could load that in, and then you could basically see, is this board manufacturable by this manufacturer, and then you could kind of like swap between them and see like what manufacturers your board is compatible with, because that would kind of save me a lot of time of plugging in 4 different types of manufacturers, make sure it's compatible with all of them, because a lot of times I like to design so that I'm compatible with all the different manufacturers in case we ended up needing to order the board from someone else for some reason, or you know, someone sponsors the team so we get free PCBs, hooray, stuff like that.
Hint, hint. That's a great question. There are a lot of different things there. I think a quick tip, which you're probably already aware of, is I think JLC, PCB, or OpAmp are some of the loosest, the lowest minimum quality specifications that you can use. And so I don't think those words really matched up. But what I mean is that if you design your board for JLC PCB's rules or OpAmp's rules, then you should be able to build those anywhere. Whereas if you use like advanced circuits, you might not be able to build that at JLC PCB. And so that's one quick idea.
That's what I typically try to do.
Nice. And then the other idea that you mentioned was having files or templates for all of these different things. So we actually have that in our template, excuse me, in our featured projects page. So you can select JLC PCB. I think this is like 4-layer. This is JLC PCB 2-layer, and you have 2, 4, and 6 at OpAmp. We're working on expanding these. If there are manufacturers that you use and like, you can just send us which ones you like, and then we can add more template design files here. This is a little bit different than how you might do it in Altium, in that this is a template project. And so all of the rules have been input into this project already. So what you would need to do is just fork this project, and then you can create your project, and it would have all the design rules of JLC PCB. We don't enforce all of the checks yet, and so you'll have to be a little bit careful about how you check those things yourselves until we get all of the rest of the DRCs in. Like, we don't enforce component to component keepouts yet. We're working on that one, but that's one instance where you would need to watch out for that. We have a dream where instead of having to export your files from Flux and then upload them straight to JLC PCB, you just have a button that says, build this board for me. And it handles all of the witchcraft on the back end for you. And one of the ideas there is maybe it would show you the 3 manufacturers that can build your board and what are the real-time quotes from those 3. I think that would save a ton of time, and you wouldn't need to go to all these different websites and upload your files to those different websites. It would all be in one place. And so that's something that's not immediately going to happen, but that's something that we're working on sometime this year.
Sounds
awesome. Jenner, did you have the JLC PCB thing up?
Yes. One sec, I might have to rejoin to share.
Okay.
Worst case,
No worries.
I can show after this as well, like the whole process.
Oh yeah, nice. We can also just do that. It's just, I mean, if you guys have seen JLC PCB already, it's just the same with Flux. You just upload the Gerbers. It's just cool to see it in the actual
that is
context.
That is nice, because sometimes I have to upload it and then I see that, oh, I am missing something, and so it's cool to see it within the software itself versus the manufacturer. But yeah.
Oh yeah, there you go.
Yeah, so we're doing this board, which I just realized I've been doing testing on this, so these components are not placed correctly. I think the only rule that we have enforced is 12 12 mil tracer widths, but yeah, took our Gerber, and they say they can make 5 for $11.
Crazy. That's crazy. Yeah. I think we're just about out of time. I don't want to keep you guys after. I know this is probably also your regularly scheduled meeting, so probably have business to talk about after this. But are there any last questions from anyone?
It doesn't look like it. Thank you very much. We really appreciate it. I'm sure that I think we're going to try to dig into the software, especially like on that strain gauge kind of OpAmp front. And if we have any feedback, we'll be sure to let you guys know.
Yeah, sounds
Love to
great.
hear
You
it.
can email us. You can hit me up in Slack. We'd love to stay in touch.